Hello, scholars. It's Dr. Ball here. So I'm going to do a couple of short videos to try and help you through this week, okay? Week 5. Many of you struggled with it. So let's start with the concept of events that a statistician or a researcher might cover. So we can see our two circles here. Notice that they're not overlapping. They are two separate circles. So if these circles each represented an event, we would say they were mutually exclusive, meaning that these events happen independent of one another. Okay? So that's the first concept you need to understand. Are these two separate events or two separate things? All right. Now, the additive law is just a set of mutually exclusive events, and we're doing the probability of one event or another event. So it's a probability that I get heads or tails. Okay. The possibilities are separate from one another. Okay. And you can see the formula I added there for you. I'm not going to focus on formulas in math because in my next video, I'm going to show you a probabilities calculator. The second law of probability talks about a joint occurrence. All right, so the multiplicative law signifies that a probability of a joint occurrence of two or more independent events is the product multiplication of their probabilities. Okay, so these are events with a joint occurrence with at least two or more. Okay, so we could have the probability of A and B. Okay, so let's say I wanted to roll the dice twice. What are the probabilities that I would get 3 and 4 in each of those rolls? Okay. We could have more than 2. We could have A, B, and C. All right, and as you can see from the formula right here, all right, probabilities of A and B and C. So we could talk about a coin flip. What are the probabilities that I get heads, heads, and tails? What are the possibilities that I pull a jack, a queen, and a king out of a deck of cards? Okay, so, and here we have calculating those. And again, I'll go over a little bit on calculations in another video. I just want you to understand the concepts. So the multiplicative law signifies the occurrence of two or more independent events. So these are two or more independent events. And this is the product of that possibility, right? So we have P, A and B equals the possibility of A times the product of the possibility of B. So if I calculate the possibility of A out of my sample, what's the possibility that I get a girl? And out of my sample, what's the possibility I get a middle school kid? Say I sampled girls and boys from middle school and high school. Okay, I'd calculate each of those possibilities, and then I would take those calculations, possibility of A, and I'd multiply it by the possibility of B. Okay, that's about as far as your math is going to have to go when you use software, but you need to understand what's going on. Now, in a conditional probability, see, I want you to understand these. You have to be able to understand the situations. In a conditional probability, one event will happen given that something else already happened. Okay, for example, the likelihood that somebody graduates from college depends upon them enrolling and completing college. Okay. So the likelihood that they graduate, they finish successfully, is dependent on them enrolling and completing. Okay, so we have a conditional event. Okay, now the additive law for mutually exclusive events, and we can see it. We can start, they start overlapping as seen by our two circles here, and you can start adding them on. But this is the probability of A or B, girl or middle school student, right? Plus the probability of B minus the sum of the probabilities of A and B and the union of events. Now, here's the formula right here. U signifies the union of events, these two things, but this probability of A or B, which we can calculate, is A plus the probability of B minus the probability of A and B. Okay. So again, we're going to use statistical calculators. Now here's something else you need to know. What is a factorial design? Or a factorial, we use this sign here, exclamation point, means it's factorial. And remember, this is multiplying a single number by each and every successive number, integer, to 0. So 10 factorial is the same as 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And here's the answer. So that's a factorial. Okay. Permutations are a different calculation, which means that we have a number of objects or items, and this pertains to the number of arrangements they can be made regarding a certain order. Okay. Combinations are not concerned with order, but they're concerned with a number of different combinations. So combinations we can think of, we could think of buying an outfit with a hat, a shirt, a purse, a skirt or pants and shoes. Okay, and then we could think about adding a scarf and jewelry, and then we could take all those things and count our items, and combinations would be any possible combination of all of or some of those items. But permutations is concerned about the order of items. Okay, so let's see if I can come up with a good example. If a science teacher has just 6 slides, how many different orders are there of showing all 6 slides? Okay, so we have just a limited and we're using all 6. How many different orders? But the combinations, we can have all those pieces to the outfit and we're not concerned about order or using all of them or just some of them. Okay. Okay, so I'm going to do another video on reading these factorial tables and using a calculator to help with your homework. Thank you very much. Bye-bye.